welcome to Ladyada.
Hey everybody, and welcome to another Desk of Ladyada. It's Sunday night at Hacker O'Clock. I'm glad that we have the redesign of the intro logo for the Desk of Ladyada that's all retro, because we are all retro. We're going to check out this Atari video machine.
Yeah, we had this whole thing planned a couple years ago, and then COVID happened, and then we're like, well, we'll get to this retro stuff because the past is always there. The past date doesn't change. The past is always going to be the past.
Yeah.
So we're back to doing the future in the past. Some programming notes. We'll be broadcasting all the shows during the week as usual. We have JP's Product Picked on Tuesday. We have Noah and Pedro doing 3D Hangouts on Wednesday. Show and Tell. Ask an Engineer. We also have JP's Workshop. And this week is one of the last deep dives with Scott for a little while. He's on leave, and he'll be back. But catch this, and we're going to have Tim Foamy Guy take over while Scott's out. So, Desk of Ladyada is here. Lamar, what's on your desk this week?
Well, do you have any news or updates, or you want to?
No, at the end of the show, we'll show our footage. We went to Washington Square Park today. It was a demonstration for world peace. All of us would like to live freely and not have our countries invaded. So today there was a demonstration with folks from Ukraine, around the world. So I'll show a little video from, this is just a few blocks from Adafruit, but that's about it.
Okay, well, let's check out what's on my desk. So I've been working on this Pi camera that I started back in the fall, and just got super distracted with a lot of part shortages, but getting parts back in so I can revisit this. So let's go to the overhead and I'll show this off. So this is this uses a camera module. Camera modules, it's interesting, a little bit like e-ink. They all kind of come with the same pinout. It's interesting, TFTs do not come with all the same pinout. TFTs all come up with like different mass pinouts. Even OLEDs are totally different from model to model. But cameras, they actually kind of came up with a nice standard for the OV7670, OV2640, OV5640. Like there's basically a series, but they're all essentially the same size, which is really nice. It makes it really easy to try different cameras at the same pinout. And the way they work is there's a couple power pins. Uses like 2.8 volt, 1.5 volt power, 3 volt power. It's a couple different rails. There is an I2C control interface where you can set settings like what mode you want it to be in, the exposure level, special effects, whatever. And then there's an 8-bit output interface that provides H-Sync, V-Sync, and 8-bit video signal on a bit clock. So the data that comes out can be in different formats. It can be in RGB format. It can be JPEG format. You actually tell the camera like what format do you want, and then you can just clock it out bit by bit, and you also get H-Sync and V-Sync out of it. You provide it gives you the bit clock, but you can provide the master clock, which will affect the bit clock. So I'm using the ESP32S2 here, the Rover module, although I'm probably going to go to the mini module in my next version. You really do want something with PSRAM, though, because you want to buffer the whole image. And while you can't DMA into the PSRAM, there is code in Espressif and also our CircuitPython core, which what you do is you DMA from the camera into a buffer that's like 2 or 3K or 4K, and then when the buffer is full, the DMA signals, and then you mem copy that into PSRAM. So you can't DMA into RAM, but you can DMA into RAM, and then when it's done, every chunk you mem copy it to PSRAM, and so you do basically double buffer, like ping pong buffer, where while the camera is filling up one buffer and DMAing it into normal memory, you're copying the normal memory to PSRAM. So that's how it works. That's how you can get very large images. Also great for JPEGs because the JPEGs easily get up to a megabyte in size. And if you want to read the JPEGs, it's best to buffer the whole thing into PSRAM, and then you can write it to the SD card at your convenience. So this is the camera. You can see I've got a little screen here outputting it. And this is in CircuitPython. I'm doing a little bit of a trick here. I'm using display IO to handle this text. So for example, you see here it says SD card OK. And I added there's an SD card here, and I added a dynamically removable SD card, so you can see it now says no SD, and then when I plug it back in, it's like, okay, I'm going to try to mount the SD card, and it failed because I've been messing with it. Reboot. Okay, so this part is, you can see like the resolution and the SD okay and normal. That's just display I/O. So I'm like having the text handled through CircuitPython, but the TFT area here, like this little, it's 240 by 176, which is like QVGA or something. That's like raw data being read from the camera, and then I like write it directly to the TFT buffer. So it's a little bit like DirectX, but for microcontrollers, because the RGB buffer that comes out of here ends up being the exact right 16-bit RGB buffer for the TFT. It's like just a nice coincidence. So we can read the buffer in and then immediately blend it out, like, in, out very easily. Obviously, you can't connect these together because this is 8-bit, H-sync, V-sync out, and this is SPIN. So you do have to, like, buffer it and then rewrite it. But it's still very fast. You can see this is, it's fast enough that you're actually getting tearing on the TFT. So things that I've implemented so far is you can take a picture. So this little button, when you press it, it says snap, and it takes a photo, and then saves it to the SD card. And then there's buttons on the back, which are going through a GPIO expander with the ATtiny 817, which is like the seesaw chip that we use. And this is for like navigating and changing settings. And I need the expander because, like, by the time you have the TFT and the camera, you basically have almost no pins left over. And the SD card, like, and anything that's built in that needs to be native, you really have like no GPIO left, because the camera needs like 8-pin GPIO plus another 4 control pins, and then the TFT and the SD card need 6 or 7, because you also want to like control the backlight and stuff. And then I have 2 analog outputs, I2C, IRQ pin here and there. So yeah, basically, for all the GPIO pads and the power pin for the camera, I needed to use an expander port. But that's okay, because the GPIO on the buttons is pretty slow. So what I did is I added a simple UI. So when I press the left and right button, you can see I can select the, I don't know if that is very visible. Yeah, I don't think it's going to show, but it's changing the resolution. So you see now it's 640. It was 640 by 480, and now it's 1024 by 768. And then I can go up a little bit more, and now it's 1600 by 1200. And then when I take a photo, it takes a little bit longer to save because it's a big image. And then down here, it says normal, but I can change it into negative. So this is like a negative effect. The camera has that built in. Basically, there's some chroma and luma settings that you can like tweak, and by just like really messing with the levels, you can basically turn it into a inversion. This is grayscale, so it's just no color data. Reddish tint, greenish tint, bluish tint, sepia, which is like yellowish tint. This is overexposed, which it's a kind of a purplish tint. Don't really know what that setting is. This is solarized, which is actually kind of a cool effect. It's like very, it's not quite negative. It's sort of like a weird exposure effect, but it's like negative-ish. It's like what people think negative is, except negative doesn't look like negative. And then, it's called solarized, and then back to normal. So taking photos and then saving them to the SD card, and then there's a little speaker. I want it to make a little clicky sound. And then there's accelerometer, which I don't know if I'll use, but I think, as you rotate it, you could have it move up and down. I thought this could be a good little open source camera interface. I know people have done camera projects with the ESP32, but the ESP32 cam is like, doesn't have any buttons, and it's really minimal, and there's often no display. Or the display is really small, like you can't get a good image, and there's no interface. There's also, of course, Wi-Fi on this, so you can use this as like a simple webcam. But you could do this. You could use this to like say take a photo every 3 minutes. You can make your own camera. You can make a webcam. You can make something that like when it moves, it wakes up and it takes a photo. So or like something that gets PIR sensor data in and that wakes it up and then it takes a photo. So there's a couple of options for what to do here. I do like the OV5640. I will say that these cameras, like the documentation is really weird. Basically there's a data sheet and it has everything in it, but like you can't really use the data sheet because there's like 5 zillion registers. So instead you have to find the app note where they basically say, look, do you want to take a photo? Here's the big register list that you want to write to the camera. And it's just like gigantic and messy and like you just kind of do what they say. Like you don't really have the ability to tweak the register values too much, although it's there, but like again, you basically are just going with the app note. Or like the Linux driver. Like nobody really looks into these cameras very much. They're very like recipe controlled. A little bit like e-ink displays where you can adapt the waveforms, but pretty much the waveforms they give you are the waveforms you want to use, or like the gamma tables for TFTs or the init instructions. Like you could come up with your own, but you pretty much just follow what the datasheet says, and you're good to go. So it's my little camera. So let me take a photo. Snap.
Okay,
and
cool.
then maybe
What
I'll
else?
show it on the computer in a bit.
Okay.
So let me go. Hold on. Let me see if it'll show up on the computer. Okay, so you can go to the computer, and then there you go. That's the photo.
Yeah,
So not too bad.
that's cool.
Yeah, the color's pretty good on these. If you use the overexposure settings
Yeah.
that they come up with. Okay, so next up, Phil, you got a Atari Video Music machine.
Yes, we're experimenting with the idea of music visualization. There's a lot of black rectangles in all of our living rooms that just sit there dormant, and we're thinking about some ideas and more to turn those into pieces of art. As usual, Atari kind of thought about this almost 50 years ago, and there is a really neat Atari Visualiser. They're very hard to find. I finally got my eBay sniping going on, and I managed to get one, and now we're just making sure we understand how it works. The schematic is part of the manual that it came, which was really rad.
Yeah.
And Ladyada is making it so we can use it. So do you want to show this thing off?
Yeah, I mean, it's what's nice about this, is, all right, so I'm over here. Rotate that. Okay. Let me know when you're set.
Yeah.
Okay, so this is the inside of the Atari Video Music machines. So this is the controls, which are like light brown, brown, and dark brown, which is very 70s shade. And this is inside, so it's pretty much all driven by this very custom chip that does all the video generation. And what's neat is these jumpers, just coincidentally, happen to be the ground, luma, chroma, and sync. And so this guy on Twitter posted this really nice little circuit where you're like, okay, just combine them with, a big resistor divider to get the sync, chroma, luma combined into NTSC. And so that little circuit board here, I just turned into a RCA connector into this little AV to HDMI adapter. This here actually normally you can see all the video is coming into here, and this is an RF tuner. So what looks like here, it looks like there's an RCA. That's not RCA, that's RF. So it transmits on channel 3 or 4, and you can get RF tuners, but it's like usually don't get as good a signal as if you just like tap into the signal directly. So what's cool is I have my iTunes going, and it's just this is the kind of effects you're going to get, and this is it. Hold on. Of course, my music just paused. There you go. It's going through all these different effects and like color, like cycles. It's kind of like an interesting thing, and I can turn up the gain. a little bit. Yeah, there you go.
Yeah,
so
it's really neat. And just to have this like running at all times, like I think folks who just have like ambient music going on in the background, this would be like a neat thing just to have like on the wall. That just displays like these cool pixelated.
This is such a thing I can imagine being advertised in like Playboy in like the late 70s, early 80s. It's like, are you a sophisticated man with a stereo system? You need the Atari Video Music Machine. So this is cool. So we got NTSC out, but one thing that's nice is because the signals are separated. The ground, luma, chroma, and sync are all separated. We joined them together into the NTSC, and the NTSC looks very good. Although the signals, it's not quite, the levels aren't quite like to standard. I'll say like the blanking signal is a little bit lower than it should be, and so what's interesting is when I plug this into the RCA directly into this monitor, it didn't like the signal levels, but this adapter doesn't mind that the signal levels are a little bit wonky. It isn't like, it's supposed to be like 0.78 volts, and it's not. It's like 1.5. But what we can do is, instead of combining all the signals together into NTSC, we can keep the chroma and the luma separate and turn those into an SVideo signal. So SVideo is a standard that came after NTSC, but before HDMI, where the signal was split, which would improve the quality a little bit, because instead of using one waveform to try to combine the hue of the color, or the hue of every pixel plus the brightness of every pixel, the brightness and the color are separated. So it's sometimes it's called like component video or like separated video. So what I want to do is, this works, so I know this is, thankfully I don't have to repair anything on this video music machine. What I want to do is change this into SVideo, and what I want to do specifically is I want to get a little SVideo connector that'll go here. So this is where this was the RF cable, and the RF cable was connected, and there was a little, what's it called, plastic, not gusset, but like a holder thingy that kept the cable in place. So I removed it, and I want something that's like SVideo that'll sit here, which is basically SVideo sized, and then I can plug an SVideo cable in very cleanly, and I don't have to worry as much about NTSC to HDMI conversion. I'll get a nice clean signal. Oh, and then this is the audio input, by the way. Even though this is yellow and white, that's just because my cable's messed up. This is not video. This is left and right audio. Okay. That's the Atari video.
All right, cool.
Okay, so my quest to find this SVideo connector that'll fit perfectly, I will go and try to find the connector, and I will find it on DigiKey in the Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
Every single week, Ladyada uses her power of engineering to help you find things on the DigiKey site, digikey.com. Thank you so much, DigiKey, for helping out with Disc of Ladyada. Ladyada, what is the Great Search this week?
All right, this week I have got my Atari Video music player, and watched this video where this person did a mod to, this version has NTSC out, but I want SVideo out, and there's this hole here, which right now I have this like cable coming out of, but what I want to do is find a panel mount SVideo connector that will fit into that hole, and I want to do it without modifying it. So the whole circuit right now, I didn't do any soldering. I just took some wires in and I twisted them around some contacts, the wire jumper. So there's no soldering been done to it, so it's like totally pristine condition. It can always be restored to its original state, which I really like. If I'm playing with hardware, I feel like I should be on expert level where I don't mess with the hardware.
Yeah, I like things where it's a parasitic upgrade that doesn't damage the original hardware. And this is nice because it kind of just like taps into what's currently there, and it doesn't damage the original in any way. So this is like kind of like the perfect mod. I actually really like this, and people really like these like pixelated visualizations. So this is just good timing as well. So cool project.
So we got NTSC working, but we want to use is SVideo because SVideo gives split, chroma, color, and luma brightness. And when you do that, it's it's a little bit easier to get better looking video out because you don't have like the chroma and the luma can affect each other a little bit. It also depends on your decoder, but if they're split, usually you get a better video quality. It's also a little bit less noisy, I've found. So I want to get that panel mount SVideo connector that'll fit in, and I don't want to do any drilling or gluing or whatever. So let's go to the DigiKey side. I was looking at inclinometers. So SVideo is kind of interesting. It's SVideo uses a DIN connector. So let's go to SVideo DIN. So it uses DIN, and DIN connectors are, they're not quite dinosaurs, but they're definitely rarer. Like, anyone who's had old Macs or even a computer with a PS2 interface, you're like, oh, I remember these kinds of connectors. These connectors, they're round. They're all pretty much like the same size, and they have different number of pins. But usually it was like 4 to 8 pins. And also these cables are a little bit cursed because you'd always put it in not quite right, and you'd force it maybe, or somebody would force it, bend the pin would break, and now the connector and the whole device is pretty much useless. So it's, this is why people don't really use DIN anymore. That said, it's the standard for SVideo. So SVideo is a 4-pin mini DIN connector. That's what we want to find. So let's go to DigiKey, and let's go to mini DIN to find a mini DIN connector. So this is a circular connector. You can also get cables if you wanted to get an SVideo cable. Like I said, we wanted to get a connector. And already things are looking good. Yes, you can see this has 8 pins, and this one has 5 pins. This one has 6 pins. This is like a good party here. And they're all totally slightly different. You can see a number of pins. So first up, of course, we want to go with active, and we want to go with 4. I don't know what PE is, but we'll go with 4 positions in the connector. So let's apply. And let's look down here and make sure that we're down to 4. Okay, yeah, so this looks right. This looks just like that Wikipedia. So there's a couple types. There's this kind of panel mount, and there's PCB mount. But again, we want panel mount. Usually I have not been going for panel mount stuff, but I want to be panel mount for sure. So let's find where panel mount is. Mounting types: free hanging, inline, panel mount, through hole right angle. So I don't exactly know what through hole right angle is, but I definitely want definitely don't want free hanging or surface mount. I don't know what dash is. So let's check those out. Okay, so we have a couple options here. So this kind of panel mount. So these are all, it's interesting. There's actually quite a few options available here. So this is that must be the through hole right angle panel mount. So it's like it goes into a PCB. But all of these actually look really good. So they all have, you can see there's this kind of bulkhead style. There's this kind of big chunky style. All of these are good. I don't know if I really care about any other size. Oh, shell size. I think that actually, so some of these are XL. These are not mini DINs. So I actually do want to make sure that they're mini DIN sized. Right, mini DIN, mini XLR. So let's go back and make sure that I'm actually getting, because DIN just means like it's the connector style. It doesn't necessarily mean the size. So let's go with mini DIN. All right, so now there's only 8 remaining. Okay, so these are all really good. So there's this style, and this has like 2 ears. You can see, hold on. There's 2 ears. How come it's always in the center? Hold on. Yeah. Okay. One moment. Maybe I'll. There you go. So there's this style, which is has like 2 ears here. Hold on. And you can like screw them in. You do have to drill 2 holes in. And then, let's see. There's this style, also has 2 little ears. This is kind of a metal plate. This is probably the most stylistically close to that era. But the one that I ended up finding was this one. And what was nice about this connector is it had panel mount, but it was slim. And then, you could pretty easily connect to the 4 pads on the back and the ground. So I actually did get these because I was working on this project last week. So let's go to the overhead and I'll show them. So this is the metal type with metal ears. This one is actually what I thought I'd end up using with the plastic ears. And I thought like, oh, maybe I'll just glue it in. What is nice about this is it has a little pigtail, which is quite handy. So like, this has it's kind of an elegant for wiring into a board. But this one, I got the one with 2 plastic rings. What's nice is that you can mount it either way. There's 2 plastic rings. You can mount it from the back or from the front. And you can solder, wires to the back pads. And then let's go to the video music device. When I got to checking out this mod, this fit in like pretty much. Hold on. I have to line up there's a little like notch, and the notch has to line up with it goes this way. This fits in perfectly. And then you can, clonk. You can screw it in from the back, and I can get to these pads, and this is nice and solid on the back here. But very easy to plug it in SVideo connector. So this was actually a perfect fit, which is pretty sweet. All right, back to my desk before I clonk anything else. So the MD40 CV, which is actually in stock right now, is my great search find, and it was the perfect part. So if you're looking for a panel mount SVideo connector, especially one that's like being used in a, looks like about 1 centimeter diameter hole, yeah, this totally rocks. And if you want the actual mounting, can you go to the computer again? The data sheet, it has the, it's a little bit more than, 1 millimeter. It's a 14 millimeter, a little bit more than 1 centimeter, but all the specs are here. And very easy to cut a hole if you need to, or if you have an existing hole and it's around this size. Also the lip gives you a little bit of leeway. So, it's not quite, it's a little bit loose, but that's all right because you just use the locking nut and you just like really torque it down. And solid, it's not going to go anywhere.
All right, that's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okay.
Okay.
We had a question, just general, and that came in, so I wanted to save it to the end.
Yeah.
Hi, Ladyada. Love Adafruit and always geek out when thinking of projects to create, but I'm not sure how to start. I saw Adabox, but how do you suggest I go about learning coding, electronics, and more?
A good idea is to pick up one of our Circuit Playgrounds. We have some Circuit Playground 4H boards and kits in the store.
I think we also have the basic kit to get started.
The basic kit we have to get started, but
Yeah.
the Circuit Playground Express is like $25, and it has everything you need. You just need a USB cable, which you probably have already, and then all the software online, like MakeCode, is free. You can use it with CircuitPython, you can use it with Arduino, and it has like everything built in, so you don't have to do any soldering. You don't need any extra tools. If you want to buy soldering tools later, you can, but you can get started with electronics and programming and hardware for basically the cost of like, a couple burritos at Chipotle.
Yeah.
And then a drink.
Next.
And nachos. There's nachos, burritos, and a drink. It's basically $20.
Yeah. The other thing is, you can get started really fast and not have that like oh no, I need to learn all of computer sciences to make something blink, start out with MakeCode. Then with Circuit Playground Express, you can pop it into CircuitPython mode. Later on, Arduino mode if you want. With CircuitPython, you plug it in your computer, it shows up as a USB drive, and you're only using a text file, unless you want to use something else, to just change things, and you're instantly making projects. Next question.
Yeah.
I was wondering if Adafruit was going to make an FPC breakout board for your iSpy displays.
I am. I actually did design one, but I wanted to get a couple more iSpy displays out before I, released a breakout. But that's the goal, is to have Featherwing and breadboard breakout. But a lot of this was because Phil keeps saying, like, when are we going to have these cool circular displays? And I was like, the problem with the circular display is how do you panel mount it in a way, or like use it in a board without like a lot of cables and wires? And so having an FPC cable is, we chatted and we ended up deciding that was the right connection to use. So we're adding it to all of our existing TFTs, and then hopefully we'll get back to some of the older TFTs to re-add it, because I think it's a very nice little elegant FPC cable connector. It also carries a lot of signals on it, so it can be used for other stuff as well, like some e-ink displays when I revise them, because e-inks are constantly changing. I'll add an iSpy connector onto those as well.
Okay, that's our show for tonight.
Okay.
I'm going to close out with a video from Washington Square Park today, and in the words of a very famous son of Ukrainian immigrants, Leonard Nimoy, who played Mr. Spock, I hope everyone lives long and prospers.
He did.
Oh, hi.
Ще банки працюють, як це як там гроші. Я солодкий не вибираю.